Hello everyone, my name is Shalini, student of SVCE. In this video, we will be learning about stacks. Here are the contents: stacks, introduction, underlying mechanics of stacks, abstract data type stacks, implementation of stacks, create, overflow, push, underflow, pop, display, combined program for implementation, applications of stacks, summary. Stacks introduction. A stack is an ordered list in which all insertions and deletions are made at one end called the top. Given a stack S is equals to A1 till AI, then we say that A1 is the bottommost element and the element AI is on the top. Stack is a data structure which works on the principle last in first out, that is LIFO, which means the last element inserted will be the first element to be deleted. The restrictions on a stack imply that if the elements A, B, C, D, E are added to the stack in that order, then the first element to be removed or deleted must be E. Equivalently, we say that the last element to be inserted to the stack will be the first to be removed. For this reason, stacks are sometimes referred to as LIFO lists. The various operations on stack are push, which mean inserting an element into the stack, pop, removing the element from the stack, overflow, checking whether the stack is full or not, underflow, checking whether the stack is empty or not. Only a single element can be accessed at a time in the stack. Then while performing push and pop operations on the stack, it takes less time, that is zero time. Underlying mechanics of stacks. Initially, a pointer, that is top, is set to keep the track of the topmost item in the stack. The top is always initialized to -1. Then a check is performed to determine if the stack is empty by comparing top to -1. As elements are added to the stack, the position of top is updated. As soon as elements are popped or deleted, the topmost element is removed and the position of top is updated. Abstract data type stack, that is ADT stack. And ADT stack is the one that shows the various operations which can be performed on the stack. It includes objects and functions. Objects are a set of zero or more elements, where functions are the parameters which are used, like stack size, which is a positive integer, S belongs to stack, item, which is an element. ADT stacks operations along with function names are given below, that is create, which creates an empty stack. It takes the stack size and creates an empty stack whose maximum size is given. Then is full. This checks whether the stack is full or not. If it is full, it returns true, else it returns false. Push. If the stack is not full, it inserts an element into the stack. Is empty, this checks whether the stack is empty or not. If it is empty, it returns true, else it returns false. Pop, if the stack is empty, it returns an error condition, else it deletes the item on the top of the stacks. Next, we have implementation of stacks using array. We have create functions, the create stack function that can be implemented as a 1D array. That is, first, here we define the size of the stack, and then we define the stack as an array, and we initialize the top value to -1. We have the representation of stack here. Here size is a symbolic constant, specifies the maximum number of elements that can be inserted into the stack. And S of size, this is an array which holds the elements of the stack. Here we have overflow. In order to perform a push operation, we need to check whether the stack is completely filled with elements or not. So we use a if statement. If top is equal to size -1. As we know that your stack is initialized or created as an array, so the indexing starts from 0, so the total size of stack will be size -1. So if top is equal to size -1, then we say that the stack is full, else the stack is not full. Next, we have push operation. This inserts an element into the stack. First, we have to check whether space is available in the stack or not. If it is available, then we increment the value of top by 1 and then we insert the item or the element into the stack. So here we check the condition, overflow condition. And then if the stack is not full, then we take the input from the user and then we increment the value of top by 1 and then insert the element. Next, we have underflow. Before we delete an item from the stack, first we have to check whether the element is present in the stack or not, if that is empty or not. If the stack is empty, there is nothing to delete. So we use a if statement, that is top is equals to -1. If the top value is -1, we say that the stack is empty. Therefore, top is equals to -1 indicates that the stack is empty. Next, we have pop operation, which is used to delete an item from the stack. So first, we have to check whether the stack is empty or not. If it is not empty, then we delete the item from the stack and we decrement the value of top by 1. We check the underflow condition. If top is equal to -1, then stack is underflow. That is, the stack is empty. We cannot delete any item. Else, we delete the item and we decrement the value of top. Next, we have display, which prints the contents of the stack. So to print the contents of the stack, first we have to check whether the stack is empty or not. If the stack is empty, we cannot display anything. So we check the underflow condition and then we print the contents of the stack using a for statement. That is, for I is equals to top, I is greater than equal to 0, I minus minus, and then we print the contents of the stack. We have a combined program for the implementation. So here first we create a stack and we initialize the top value to -1. We have the main function. Here we give the choice to the user. The user can select the operations like push, pop, display, or exit. Then we take the input from the user and we have a switch statement. In that first case is push, then second is pop, third case is display. In default, we say that you have entered a invalid choice and we exit from the program. And in the push function, we check the overflow condition and then take input from the user and then increment the top value and insert the element. In pop, we check the underflow condition, delete the item and then decrement the value of top. And in display, we check the underflow condition and then print the contents of the stack using a looping statement, that is for. Next, we have applications of stacks. Stacks are used in function calls. They are used in conversion of expressions, that is arithmetic expressions, evaluation of expressions, and arithmetic expression represented in the form of either postfix or prefix, and used in recursion, undo mechanism in software, backtracking algorithms, memory management, browser history, parsing expressions, algorithm implementations, balancing symbols, task management in operating systems. These are the applications of stacks. Summarizing the prior slides, a stack is a linear list of elements in which an element may be inserted or deleted at only one end, that is called as the top of the stack. And stack works on the principle last in first out, LIFO. The top is always initialized to -1 and various operations can be performed on the stack like push, pop, overflow, underflow, display, and using these operations we can implement the stack. And it has a great importance in the conversion of infix expression to postfix expression. Thank you.